Hello everybody. In this video we will learn different terms. Uh, but right now let's start with accuracy and precision. When we talk about any science subject, any scientific data, any scientific process, we use these terms, accuracy and precision. You will be doing labs, you will be doing your science fair project, many things where you have to produce precise and accurate results. Well, what is the difference between precision and accuracy? Precision means that over and over I can produce the same kind of results. It's reproducible, no matter how many times I do it, I get the same data. So regardless it's right or wrong, like the density of the water is 1.0 grams per milliliter, but if for some reason I'm calculating 0.71 grams per milliliter, my answer is wrong. It's not accurate, but if I am doing it over and over and this is what I get, and my data is precise, you know, even if I round it up, it becomes 0.7. So this data, which is reproducible, it is precise. But for it to be accurate, my answer has to be 1.0 grams per milliliter for the density of water. So precision means it's reproducible. Accuracy means it got to be correct. If it's not correct, it's wrong. It is not accurate. How can I get precise data? By doing repeated trials. How can I get accurate data? By changing my method or using a method that can provide an accurate data. Poor precision results from poor techniques. Maybe some kind of error that we make while we are doing a process. Whereas poor accuracy results from, it could be a wrong procedure that I was using, or there could be a flaw in the equipment. So that's why I don't have the accurate results. But sometimes but regardless I have accurate or not, I should have a precise result. If I'm not having a precise result, that means I'm using poor techniques. So one more time, as I said, precision means that data is very close together, right or wrong, regardless. Right or wrong, regardless. It has to be close within a set. So if I repeated this thing 4 times, every time I got the same result. That means my data is precise. But if I calculated it 4 times and my result has to be 1.0 to be accurate. If it is not 1.0, it is not accurate. So it has to be equal to the known value, the actual value, the literature value. So this is the difference between precision and accuracy. You need to practice certain questions on this. For example, there is a dot game. So precision means, regardless, you were not able to hit the target, but no matter how many arrows you used, they were all pretty close together. So this data is precise, but it's not accurate. It is precise, but it is not accurate. All right, how about this one? This is precise and accurate because I was able to get the target and I was able to get them all right. Okay, this is accurate but not precise, and this is neither accurate nor precise. Okay, so it's none. Okay, this is accurate and not precise. So this is how you need to get the concept of precision. There should be a worksheet that you need to work on to get the practice on precision and accuracy. The next topic we want to learn is percent error. Okay, so when your data is not accurate, of course there is an error in your answer, and we want to see how much the error is. As I was saying, that the known value of density for water is 1.0 grams per milliliter. But what I just gave you an example that, for example, I have 0.71 grams per milliliter. This is student data. This is what the student calculation is. So this is not accurate. So there is an error in this data or in this lab. So I want to calculate what percent of error is. So I'm going to use the formula that known minus experimental divided by known. So you make sure you understand that it has to be divided by known, and it's an absolute value, so the answer will never be negative. So regardless, even if this number is smaller than this number, if the known value is smaller than the experimental value, that is fine. There will never be a negative answer. So please, I repeat that there will never be a negative percent error, because if there is an error, it's an error. How can it be negative? So based on the example that I have right here, my known is 1.0 and my experimental is 0.71, and then I have to divide it by the known, which is 1.0, and then I multiply it by 100. Why am I multiplying by 100? Because I need to calculate percent. Percent means out of 100. Per means out of, and cent means, of course, 100. So I always have to multiply by 100. So you have to memorize the formula: known minus experimental divided by known, and it's an absolute value, so the answer will never be negative. Um, absolute value means no negative percent errors. So again, I'm repeating it because I get these questions a lot. Oops, where am I? So, all right, so let's move on. The next topic I want to talk about is significant figures. Significant figures are very important when we collect data, when we are working in a lab. So because these are the digits, we want to know that when we have any data, which part of it is significant or which part of it is not significant. What is it that we can roundly ignore? What part of it is that I must know what I'm doing? So there are different rules to calculate significant digits. So significant digits consist of known digits or estimated digits. Known digits means they read directly from the measuring equipment. So if you are recording the volume from a graduated cylinder, so whatever the volume is, that is a known digit. So whatever you're reading right exactly from the equipment, that is a known digit. Estimated digit, that I always add one number to my known digit. So if the volume right now is 5.5 milliliter, this is exactly what I can read. I will say it is 5.50 milliliter because I have to add an estimated digit. It just tells me how precise my equipment is. So estimated digit is always one digit that is added to your known value. So I repeat that when you're recording the measurement from a graduated cylinder, and even if I can read exactly it is 5.5, I would have to add one estimated digit to this. So this 0 is the estimated digit and 5.5 is the known value. So there's always one digit that you add, and that is only one estimated digit. So we can do a lot of practice on that in the class. So counting numbers and metric conversions are real examples of exact numbers. What is the mass, what is the volume, what is the temperature, and they can have infinite number of significant digits. But always keep in mind that units are important. So let's go ahead and learn how to count significant digits. Well, anyway, before that, let's see how to estimate digits. So what do you think here? How many? It is incremented by what? It's 60, 61, 62, 63, 64, 65. So it's incremented by 1 milliliter, right? Now, when I read it, it tells me 1, 2, 3. 63 is right here, and as I see it in my pen, my line is not very much straight, but no matter what, you see that it is a little bit more than 63. Okay, so known is 63 for sure, and now I'm going to add a little bit to it. Okay, and I'm going to estimate that. And since I'm going to estimate it, not necessarily everybody is going to estimate it exactly the same. So I probably think it is 63.5, because it is between 3 and 4. So I can say, okay, well, I think it is 63.5. You probably think it is 63.6. Somebody else may think it is 63.4. And all of these are right answers, okay? Because we're estimating this digit, and we can estimate it differently. What you cannot be wrong is 63. So as long as the 63 is good, we are good with the values. what is wrong? What could be further wrong with this calculation? If you say it is 63.50, well, this is a wrong data, because you're estimating this and you can only estimate one digit. Here you're telling me you for sure know it is 63.5, and now you are estimating this one. So you cannot estimate two digits. So this will definitely be a wrong answer. All of these answers could be right, but this is a wrong answer because we can only estimate one digit. So please keep that in mind when you're recording the volumes and temperatures. All right, so let's see what's next for us. All right, so now next for us is estimating, counting significant digits. So make sure that you learn how to calculate estimated digits, and do a practice on this. I'll give you enough practice in the class, and you must show me your answers to make sure you're right, because these questions could be on your quiz, they could be on your test, and they are there is a possibility they are on your SOL exam. So we must understand how to count known and estimated digits. Well, speaking of significant digits, let's learn how to count significant digits. So there are 4 rules. We are going to learn how to count significant digits by 4 rules. The very first rule is that all non-zero digits are significant. So any number that goes from 1 through 9 is significant. So 0 is not significant. So non-zero digits are significant. Like 2, 5, and 6, none of them is 0, so there are 3 significant digits. If I say 1 and 2, none of them is 0, so there are 2 significant digits. If I say 3, 3, 3, none of them is 0, it's 3 significant digits. 4, 56, 3 significant digits. If I say 4, 5, 6, 0, this 0, I said 0 is not significant, so I'm not going to count this. It is still 3 significant digits. So keep it in mind that non-zero digits are significant. What is the next rule? The next rule is that the zeros between non-zero digits are significant. We call them trapped zeros. So if I have a trapped 0 or a sandwich 0, it is significant. So if I have the zeros between the numbers, 3, 0, 3, 2, 0, 2. So these zeros which are between the digits are significant. I'm going to count them. So I got 3 here. This is also between, so I'm going to count 3 here. And this is between these, so I'm going to count them all. So 1, 2, 3, 4. I'm going to count 4 here. So this is the second rule. The first rule was that as long as it's not 0, you're going to count it. 1 through 9, everything is significant. Second 0, the 0 is only significant if it is between the digits. Now, which other 0 is significant? The trailing 0, the 0 that is at the end of the number. Okay, the trailing 0 is significant. The trailing zeros are significant. So there is a decimal point in the number. They're only significant if they are followed by a decimal point. If I have a trailing 0 like this, 750, this end 0 doesn't have there is no decimal point before it, so I am not going to count it. It's only 2 significant digits. If I have 7.50, now this trailing 0 is after the decimal point, so I will count it. So it is 3 significant digits. So I count this one because it is trailing 0, the end 0, after the decimal. And I count this 0 because it is sandwiched. So I will count all of them. It's 4. And this I said is only 2. So if I have 300.3.0, how many significant digits it's going to be? According to second rule, they are significant, and according to the third rule, this is significant. So I will count all of them. Whereas on the other hand, if I had this one, I will not be counting this. I will only be counting these. So it will be 4 significant digits. The last rule is that the leading zeros are not significant. The zeros that are in front of the number, regardless that they are after the decimal point or before the decimal point, it doesn't matter. These are after the decimal point, this one is before the decimal point. Does not matter. As long as they're in front of the number, they're leading zeros, they're not significant. So I'm only going to count these 2. So for example, if I have 0.00300, I will not count any of these because they're leading these zeros, but I will count these. So there are 3 significant digits. So counting numbers and defined constants like metric conversions have infinite significant digits. You know, like 1 meter is 1000 millimeter. So this has infinite number of significant digits. So we don't worry about that one. When we are doing the math, we want to know the values that are based on these rules. The next thing you want to know that how to round up the significant digits. The rounding rules are the same as you have ever learned before. You know, if I have to round 673.8 to 3 significant digits, my third significant digit is right here, you know, 1, 2, 3. So if this number is more than 5, I will round this up to make it 674. If it was 673.2, and I was going to round it to 3 significant digits, this is my third significant digit, and this number after that is less than 5, so I'm not going to count it. My answer will be 673. So these are the general rounding rules that we are going to apply in this situation. So so round the following to 3 significant digits. So I have 1, 2, 3. So I'm going to round it right here. So I have to see what is the number after this. You know, this is my third significant digit. So I'm going to look at this number here. So this number is less than 5. So I will not be rounding it to the round. I will not round it up. I will round. So I'll keep it the same. So it will be 125. This is 3 significant digits. How about this one? I'm going to round it right here again up to 3. This is 1, 2, 3, and this is more than 5, so it goes to 482. So this is 3 significant digits. So rounding rules are the same as you have learned before. Where are we going to use these significant digits? We are going to use them in all 4 calculations that we generally do. You know, plus, minus, multiply, divide. So there are rules to follow that. And from here on, any mathematical calculation that you do in this class, you have to follow the significant digit rules. And no matter what questions we are doing, it's not that just for this lesson or just for this unit or chapter, regardless, wherever you are doing a math, you are going to follow the sig-fig rules. Otherwise, your answer will be wrong. There could be some circumstances where I can tell you that ignore it. So then, of course, you could. But if you are told, if you're not told anything, you know, if you're not told to ignore it, you have to keep the significant digit rules in mind. So let's see, what are the rules? The rules for addition and subtraction. You know, no matter whenever you're adding, whenever you're subtracting, you need to follow this rule. What is the rule here? The rule is that for addition or subtraction, you are going to match or round your answer to match the least precise measurement. Okay, so this is, you have to go by the least number of significant digits after the decimal point. That means the least precise measurement, because the more the numbers are after the decimal, the precise the data is. So here I have only one significant digit. This 0 is significant because it is the trailing 0 after the decimal point. So this 0 is significant. Here I have 2 significant digits after the decimal point. Here I have 2 significant digits after the decimal point. Here it is 1. So I'm going to only round my answer to the 10th place because this is my least number of significant digits after the decimal point. So if this is what the calculator gives me, I'm going to stop right here. I will not count this. So please keep it in mind that I have to round it to the nearest 10th, not the 100th, because the least precise data was up to the 10th. So here I have a whole number. There is nothing after the decimal point. Here I have 2 significant digits after the decimal point. Okay, I have 1 significant digit after the decimal point, and here I have none, you know, nada. So I have a whole number. That means my answer got to be the whole number. Okay, I cannot have anything after the decimal point. So if this is what the calculator gives me, I need to turn this into a whole number. Okay, because this is what I have for a whole number. So I will only take it to 210. So I have to make it to the nearest 10th. What are the rules for multiplication or division? You need to round your answer to match the least number of significant digits overall. You're not only counting after the decimal point. We are not looking for the precise, least or most precise data. We are just looking for overall. We have 3 significant digits here, 3 significant digits here, and only 1 significant digit here, because leading zeros don't count. Remember the significant digit rule, that leading zeros don't count. So these zeros don't count. I only have 1 significant digit here. So when I multiply these 3 numbers, this is the answer that I get from the calculator. And I need to round it up to make sure that there is only 1 significant digit in my answer. So this is where I will round it up. Don't be scared or don't hesitate to round big or too small, because we need to make sure we follow the sig fig rules. So I repeat it. We are going to count all significant digits in the number. So 3, 3, and 1. And when I have this big, huge number from the calculator, I have to round it all the way to 900 to make sure I have only 1 significant digit. The trailing zeros don't count if there is no decimal point. So these zeros are not significant, but yes, I'm going to write them. So example number 2, I have 4 significant digits right here. I have 2 significant digits right here. So I'm going to choose the least number of digits. So I'll just choose the least number of digits. So let's say, all right, so least number of digits. I have 4 here, 2 here. This is what calculator gives me. So my 2 digits will be right here. Okay, so I'm going to decide whether to round it right here or not. So since it is 15.312, I will just take 15. So I hope you understand that when we multiply or divide, we are going to go by the least number of digits in our data. When we add or subtract, we are going to go by the least number of decimal spaces. So least number of decimal spaces in the data. If the data has 1 decimal space is the least one, then my answer should have only 1 decimal space. If my data has no decimal space, then my answer should not have any decimal space. So these are the significant digits that we need to follow no matter which calculation we are doing at any point of this year. You're calculating moles or grams or liters or density, a molarity, regardless, you are going to follow the sig fig rules. Okay, so this is about it. That's all for today. Please make sure you take notes, do all the practice problems. Your pacing guide tells you what practice problems you need to do. Please complete the practice problems and ask me any questions in the class. Thank you very much. Thank you for your attention. I'll talk to you later.